It's the same principle that we're doing with these brain implants. This is called neuroelectrophysiological recording.
Could the story of human evolution be about to take a radical turn? With Elon Musk's creation, Neuralink, starting human trials at an early level, the prospect of combining artificial intelligence and humans becomes more plausible than ever. However, what does this signify for humankind's future? Get ready for an exciting voyage into the future of mind-bending technology and the moral dilemmas that it poses. But what social ramifications and moral problems can this innovative technology bring up? Let's get started. According to a tweet from Elon Musk on January the 29th, Neuralink, the business he founded with the goal of revolutionizing the brain-computer interfaces, has successfully implanted a brain-reading device into a human for the first time. In order to enable a person with severe paralysis to operate a computer, robotic arm, wheelchair, or other devices just by thinking, brain-computer interfaces capture and decode brain activity. In addition to Neuralink's gadget, several others are being developed, and some human testing has already taken place. Researchers in neurotechnology are enthused by Neuralink's human study, albeit cautiously. I expect that they'll be able to prove it's secure. It works well for measuring brain impulses over the long term, as well as the short term. According to Mariska van Tienzel, president of the Global BCI Society and a neuroscientist at the University Medical Center Utrecht in the Netherlands. However, the absence of comprehensive information is irritating. Apart from Musk's tweet, there's been no official announcement that the experiment has started. A study leaflet encouraging people to join in the trial serves as the primary source of public information about it. However, according to Tim Dennison, a neuroengineer at the University of Oxford in the UK, that doesn't include information about the precise outcomes that the research will evaluate or the location of the implantations. The US National Institute of Health maintains an online repository where the trial is not registered. Before study participants are registered, several universities mandate that researchers register a trial and its protocol in a publicly accessible library of this kind. Additionally, in accordance with ethical guidelines intended to safeguard study participants, many medical publications need this registration before results may be published. Nature contacted Neuralink, whose headquarters are in Fremont, California, to inquire as to why the experiment hasn't been registered with the website. Neuralink did not reply. Have you ever wondered what exactly Neuralink is and how it works? The CEO of Neurable, a neurotech business creating non-invasive brain-computer interfaces in the form of headphones, Ramses Al-Qaid, stated that Neuralink is a technology company creating a gadget designed to connect human brains directly to computers. Neuralink's technology can record and decode neural impulses and then use electrical stimulation to send information back to the brain. The link is the name of an implant itself. This brain chip, the size of a coin, is surgically inserted beneath the skull to collect input from neural threads that branch out into various brain regions to regulate a subject's motor abilities. According to Neuralink's website, each wire has sensors that can record and produce electrical currents that are so fine and flexible that they can't be inserted by the human hand. Neuralink has created a neurosurgical robot that can operate entirely on its own. Additionally, the business is creating an app that would let users use just their minds to control a keyboard and a mouse. Summer Norman, a scientist with non-profit startup Convergent Research and a former principal brain-computer interface scientist at software company AE Studio, said of Neuralink, "Neuralink is really at the vanguard of creating the commercialized, scalable versions of what's been pioneered in academia. Decades of scholarly research have been conducted to advance this field to its limit, but in the end, it becomes a very expensive area to develop," he stated. On the other hand, you might be curious to know how this works in reality. Do you agree with this? Let's have a look. According to Norman, the fundamental technology of Neuralink functions similarly to electrophysiology. Our nervous system's electrical and chemical messages ignite when neurons connect through synapses, which are openings between nerve cells. Electrodes or voltage-detecting sensors record this brain activity by measuring the shift in spikes that occur when these voltages fire or may fire. Put differently, our brain activity is recorded not only when we act, but also when we merely consider doing. That being said, mind reading is not the same as the brain-computer interface performed by Neuralink. It basically gauges brain activity and interprets it as a movement, explained Sonal Barberwell, a researcher at Dublin City University who creates machine learning algorithms for wearable brain-computer interfaces. Barberwell compared this process to how a patient's blood pressure indicates how stressed or at ease they are. He says that the brain can also detect certain aspects such as your eyes closed or opened, a relaxed or deep sleep state, and an action or focus state. Machine learning algorithms and other artificial intelligence agents are utilized to interpret the complex datasets that these devices record. The company's primary objective, according to the Neuralink website, is to assist those who've been rendered paralyzed in regaining their lost communication abilities. Its future goals include treating neurological conditions and regaining motor, sensory, and visual abilities. According to Al-Qaeda, by establishing a direct interface between the human brain and digital devices, a Neuralink device has the potential to enhance human memory, processing speed, and cognitive abilities. Exoskeletons and prostheses can be operated using brain-computing interfaces. Al-Qaeda claims that this use case would allow individuals who've lost limbs or are paralyzed to regain some degree of mobility and freedom. The primary goal of Neuralink is to facilitate communication between those who are unable to write or talk by giving them the ability to use a virtual keyboard and mouse or send messages with their thoughts. For instance, a person with paraplegia could use text synthesis or speech recognition to control a computer or mobile device, browse the internet, and produce digital art. Do you know that Neuralink could help identify conditions? Brain-computer interfaces, according to Al-Qaeda, can monitor brain activity and identify changes that might be indicative of neurological disorders, including epilepsy, bipolar disorder, obsessive-compulsive disorder, Alzheimer's or Parkinson's disease. They can also be used to track symptoms related to mental health, as a treatment for burnout, weariness, anxiety, and depression, which, unlike motor abilities that are restricted to one location, are disseminated across the brain. Electrical stimulation might be applied to specific areas of the brain, according to Norman. Developing brain-computer interfaces and neuroprosthetics for individuals with neurological injury or disease has been Norman's focus for the past 10 years. Treating or curing paralysis, neurological disorders, and injuries could make the world a substantially nicer place, where very few people have untreatable forms of depression or anxiety, Norman said. Restoring agency to those who've lost it is an indisputable advantage. What do you think about this innovation? And that's all about it. If you like this video, please give a thumbs up, and if you like more AI updates, subscribe to our channel. Don't forget to click on the bell icon to not miss out on any video and to get notifications on time. Don't hesitate to give suggestions for the videos. See you in the next one.